Today we are going to look at physical and chemical changes. In a physical change, the substance involved remains the same substance. Even though it may change form, state, or even dissolve, the particles are still the same particles. So for example, ripping paper. When you take a piece of paper and rip it up, it still is paper particles. It just has changed the form. When you break glass, the particles are still glass particles. They are just in a different form. We still have the same substance. And if you crush a stone, the particles of stone are the same. They're just in a different form. Melting gold. When gold goes from the solid to the liquid state, it's still our gold particles, just in a different state. When we evaporate water, taking water from the liquid to the gas phase, it still is the same substance. When we dissolve sugar in water, the water particles are spreading out. We still have the same substances. And when we dissolve carbon dioxide in pop, the solvent particles are spreading out. The solvent is the substance that the carbon dioxide is dissolving in. So water and pop are the solvent particles, but they still are the same substances. In a chemical change, the original substance is changed into a different substance that has different properties. The particles in the new substance are different from the original ones. So for example, if we burn toast, it's an entirely new substance. It started out as bread, then you cooked it, toasted it, and that already made a chemical change, and then burning it is even further, more chemical changes. Rusting a nail. When it goes from being a regular nail to having rust on it, that orangey color, we have created a new substance. It still seems like a nail, but you can take the rust particles and remove them. They're totally different substances. And when an apple turns brown after you cut it, you have a new substance. It's still an apple, but those particles that started to rot or became brown are new particles. How can you tell if it's a chemical or physical change? Some clues that a chemical change may have occurred. A new color appears. So for example, when copper changes to green, when it gets exposed to oxygen in the air, such as the Parliament buildings. The roof would be copper colored, but it continues to become green with time. When heat or light is given off. So when fireworks go off, there's definitely a lot of heat and a lot of light, and color for that matter. Bubbles of gas are formed when you mix baking soda and vinegar together, just like we did in our last experiment. A solid material or precipitate forms in a liquid. So for example, when milk sours and gets chunky. The change is difficult to reverse. So for example, cooking an egg. All of the examples above are difficult to reverse. You cannot unsour milk. You cannot undo baking soda and vinegar mixed together. You cannot undo a firework. And you cannot undo copper becoming green when it gets exposed to air. So those all are examples of changes that are difficult to reverse. Now let's take a look at what it looks like at the particle level. Physical changes do not change the original substance. So for example, water, H2O, exists in 3 states. So these are examples. That's a water molecule, and in the solid state, all the water molecules are very close together, tightly packed in rigid positions. Then when it melts into a liquid, the water molecules are further and further apart, but they can move around. They're still close together, but they still are water molecules. And then if the liquid water becomes gas or steam, when you boil it, the water molecules are really far apart, but they still are water. So this is an example of a physical change, the same substance in a different state. Chemical changes, however, do change the original substance into new substances. So for example, if we look at the particles in iron in a nail, so iron atoms look like this. When they react with oxygen in the air, they form a new substance called iron oxide. And that's that rusty color that you see. So these are iron atoms and these are oxygen atoms combined together. Totally new substance. So that's the difference between physical and chemical changes.